Hey math students! Today we're continuing our lesson on the inverse function. We're going to learn how inverses are used in the real world, along with how to solve for inverse equations. Make sure that you have your notebooks out, you're prepared to take beautiful, gorgeous, organized notes, and go ahead and get started on the warm-up. Okay, welcome back. So, here's what I got for the warm-up. Ooh. Let's move this a little. There we go. So everything that I use to solve the warm-up goes back to this idea at the top. So this equation up here is extremely vital. And it's just the idea that when you take the inverse of a function, then the dependent and independent variables switch. So just a reminder with your vocabulary, x is your independent variable, right? And then y is your dependent variable. The inverse switches those two things. So we're going to be using this concept for the whole lesson today. So make sure you write that down and you understand what is happening there. So for instance, with the first problem, I was given a function h and values of h, so h of 3 equals 1/2. So to find h inverse of 1/2, I would use the x value as my output now. So the independent and dependent variables switched, so that now the inverse function is equal to the independent variable 3. Problem 2 is very similar to that, except we're given a graph instead of an equation. So this is a graph of f of x, just to be clear. So this is a graph of f of x, but I'm trying to find values of f inverse. So the values that I'm trying to find are of f inverse. So that means I need to use the x and y points on the graph, but switch them. So if the input that I'm looking for is 0, so the input of an inverse function would actually be the y value. So I highlighted in red the points that had a y value of 0, and then the x value is -2. And then I highlighted in yellow the points that had a y value of 1, and then the x values were -1 and 3. There were 2 of them. So that was a little tricky. But again, I'm just using that same equation that's at the top of the page. If this warm-up was tricky for you, it might be important for you to rewatch the first inverse video that I posted so that you really understand these concepts. Otherwise, we're going to keep moving. So, just to start, why are inverses even important? And to be honest, you have been using inverses ever since you learned how to solve your first equation. So if you see that equation highlighted in yellow, it's pretty basic. It's 3 equals x plus 1. And you can probably solve that equation in your head. What is the value of x? And a lot of you will be able to say, well, of course, x equals 2. And I would say, how did you get that? How do you know x equals 2? And a lot of you would say, well, I knew to solve for x, I had to subtract 1. So you subtracted 1 from both sides. And I'd say, how did you know how to do that? You'd be like, because I had to cancel out the 1s. And so this idea of canceling out to isolate the variable, we wanted to isolate x or get x by itself. And when we cancel out, we're actually using inverses. So remember that cancellation equation? So this is a cancellation equation, or this is a cancellation equation. Means if you put a function and its inverse together, they cancel each other out. So what this is telling me is that addition and subtraction are inverses. They cancel each other. Multiplication and division, they're inverses. They cancel each other. A square and a square root are inverses. They cancel each other. So you've been using inverses this whole time. Amazing, huh? We also have been using them in the real world. So let's say that you just came back from a trip to Mexico and you have pesos and you want to convert them to dollars. So you would have to use this equation here to turn your pesos, like if you had 200 pesos into dollars. So you take P, multiply it times 0.047, and then that's how many dollars you would have left. Okay, so let's think, if I have this equation, what if I go back to Mexico and then I have all these dollars and I want to turn them into pesos? This is where, again, we would use the inverse equation to do the opposite. So now I have dollars I want to turn to pesos. So my original equation, which is right there, I can think of this as a function that takes a peso and turns it into dollars, right? So my independent variable here is P, and my dependent variable that I get out is D, dollars. If I wanted to do the opposite, my inverse would take a dollar and turn it into pesos. Does this look familiar? It should look almost exactly like that equation at the top of our warm-up, right? Switching the x's and y when you do the opposite. And so then the equation looks like this. And you can see that it has the opposite function in there. Instead of multiplying times 0.047, I use the inverse operation, which is division, and I divide the dollars by 0.047, and that would convert my dollars into pesos. Very cool. So let's do like a little example of this, a real world example. So a college uses the following equation to determine the cost of tuition. T. So T is the cost of tuition based on the number of credits, C, that a student is taking. So credits are kind of just like classes. So if I'm taking 15 credits, that might be the same as like 5 classes. So credits are like classes. And so the equation that the college uses is right here. So f of C equals 86C plus 15. So the more credits that I'm taking, the more that I pay in tuition. And what I get out ends up being my tuition amount. So for instance, if I take 5 credits, that would be 86 times 5 plus 15. That equals, oh no, that doesn't look like a dollar sign. That equals, there we go, $445. And this is the tuition, in tuition. Okay, so 5 credits means that a student will pay $445. So now I want you to think about this other way. Now I want you to explain the meaning. If I take the inverse equation, so F inverse of 445 equals 5, what does that mean? So let's write this out in words. This means a student who has $445. So let's say instead of a student, maybe in the original equation up here, this is if you're like, okay, I want to take 10 credits, how much will I pay? Or I want to take 15 credits, how much will I pay? This inverse equation works a little different. The inverse equation works as like, okay, I have this much money, how many credits can I take? So it's working the opposite way. All right, if I have $200, how many credits can I take? If I have $1,000, how many credits can I take? So the brain is switching what you're thinking about. So now a student who has $445 can take 5 class credits. Okay, so that's the way we would rewrite that inverse equation in words. Whereas this one would be a student who takes 5 class credits will pay $445. These sentences are almost the same, but the independent and dependent variable have switched. So we've switched what is deciding for us what's happening. So in the yellow original equation, the independent variable was how many credits you want to take, and in the green inverse equation, the independent variable is how much money do you have. Both equations are good. They're just thinking about it a little differently. Now we're going to focus a little bit more on the procedure. So we're going to be looking at problems that look like this, that give you some sort of function and then asks you to find the inverse of it. Okay, so this is a little bit more procedural math. So how to take a function and then calculate the inverse. So here are the steps that you should follow for that. And all of these are still coming back to this glorious equation, the fact that an inverse function switches the independent and dependent variable of the original function. Okay, so here are the steps. It's important for you to just write these down, make sure you have them in your notebook. So 1, you'll change the function notation from f of x to y. So let's say I have I'll just give a basic example. F of x equals 3x minus 2. So my step 1 would be to write it as y equals 3x minus 2. Step 2, change all the x's to y's and y's to x's. So I'm going to change that to x and this to y. Step 3, solve for y. So step 2 is important. You can think of this as switch the independent and dependent variables. Same thing we've been talking about this whole lesson. So that's where that comes in, the switch. And then after we've switched, we still want to solve for this in terms of our y. So this is a 2-step equation. I'm going to start solving for y. I'll do this in red, make it clear. I'm going to add 2 to both sides. So x plus 2 equals 3y. Then I will divide by 3 to get y equals x plus 2 over 3. I kind of ran out of room. Hopefully your notebook is still going. The last step is just to replace y with y in f inverse. So at this point I've found the inverse successfully, so I'm just going to rewrite it back in my proper notation. So f inverse of x equals x plus 2 over 3. X plus 2 over 3. So since my original equation was written in terms of f, my inverse will be f inverse. Okay, let's do some more examples on the next page. Okay. Alright, so what's my first step? Yes, rewrite in terms of y. So instead of h of x, I have y equals the square root of 3x. My second step, switch the x's and y's. So this will become x equals the square root of 3y. I switched my independent and dependent variable. And now I want to solve for my new variable, my new y. So I'm always going to just start doing this step in the same step as 2 so that I can conserve space. I don't like writing more than I have to. Neither should you. You should conserve your energy. So first I need to get rid of that square root. So what's the inverse operation to a square root? A square. That will cancel out a square root. Those are inverse operations. So then I have x squared equals 3y. And then I will divide by 3, because division is the inverse operation of multiplication. So x squared divided by 3 equals y. And then my final step 4 is to rewrite in my inverse notation. So this will be, my original function was h, so I will write h inverse of x equals x squared over 3, like that. Cool? Cool. Okay, and then let's keep going. So part B, I'll start by rewriting it with y. step 2 is to switch the x's and y's. And then we've got to solve for y. So switching back to red, solve for y. Whenever you're solving for a problem, you've got to kind of start from the outside in. So first I've got to get rid of this 3. Trying to get y by itself. Now I need to get rid of that cube, that power of 3. How do you cancel out a power of 3? With a cube root. This is a little too crowded right here. Make some more space. Okay, there. So you take a cube root on both sides. So a square root cancels out a square, a cube root cancels out a cube. So on the left-hand side, I will have cube root of x plus 3. And then the cube root and the cube cancel out, and I'm just left with y plus 1. And then my final step, addition and subtraction are inverses, so I will subtract. And I have cube root of x plus 3 minus 1 equals y. And my final step 4 is to rewrite it in inverse notation, since I found the inverse. My original function was g, so I will call this g inverse of x equals the cube root of x plus 3 minus 1. Alright, hopefully those ones weren't too bad for you, because now we're going to do the challenge problem. So I want you to look at this problem in C, and I want you to try to figure out what makes this a challenge problem. Why is this problem going to be a little bit more difficult than the other ones we've done? What's harder about this? Some of you might see it. It's the fact that we have 2 x's. This problem's going to end up being more challenging because we have 2 x's. I'm going to show you why. So I'm actually going to combine step 1 and 2 together to conserve space. So I'm going to write it with y notation. So I'm going to change f of x to y, and I'm going to immediately just switch the x and y's. If you don't want to do both steps in one, you can split them up into 2. I will let you do that. But I don't like writing more than I have to. Oops. I almost made a mistake though. That's the issue with taking shortcuts. You might make a mistake. But this is good now. So I changed f of x to y, and I switched the x and the y's. So now you can see, oh my gosh, I have these 2 y's. Which is a little challenging because step 3, if you remember, step 3, I need to solve for y. Okay, solve for y when we have 2 y's is a little bit challenging. So what I need to do is, here's my little strategy. I'm gonna get rid of the fraction, because we all hate fractions, right? Get rid of fractions. It doesn't make sense to have one y in the numerator and one in the denominator. We eventually need to combine them together. So first step, I need to get rid of the fraction, and I'll do that by multiplying times y plus 3 on both sides. So y plus 3 on both sides will get rid of the fraction. On this side, I'll just be left with 3 minus y. And then I'll be left with x times y plus 3. So remember to use your parentheses on the left. So the fraction is gone. I still have 2 y's. That kind of stinks. So my next goal is to get the y's on the same side. So I'm going to get the y's on the same side. So the first thing I'm going to do is distribute right here. So that's x times y plus 3x equals 3 minus y. So not only do I want to get my y's on the same side, I want to get everything else, so and everything else, on the other side. So I'm going to get my y's on one side and everything else on the other side. So let's get our y's on the right hand side. So that means I want to move this y, this minus y, over, and I will do that by adding y. And then I will subtract that 3x. So I want this 3x to not be over there because it does not have a y. So then I have x times y plus y equals 3 minus 3x. I'm getting closer. So I don't have a fraction anymore, and now my y's are on the same side, but I still need to combine them together. So this is like a big move that we're going to do right here. What we're going to do is we're going to factor out the y. And watch what happens when I do that. So on the left hand side, I see that I have my two terms with the y. I'm going to factor it out like that. Holy smokes, I only have one y now. That's amazing. Okay, so I only have one y. I just have my final step now. So I got my y by itself. I'm just going to divide by this x plus 1. And I'm basically done. I can't zoom in anymore, unfortunately. So I have y equals 3 minus 3x divided by x plus 1. We did it. It was a lot of work, but we did it. We got the y by itself, and then we just have this last step of rewriting this as the inverse. So the inverse will be f inverse of x equals 3 minus 3x divided by x plus 1. Amazing work. So if you were ever solving for an inverse and you're like, I'm not sure if I did this right, a great way to check your work would be to graph it. So I graphed the original equations in red. So you can see we have our red square root, our red cubic function, and then our red reciprocal. And then in black, I graphed all of our solutions. And you can see that the black solutions are a beautiful reflection over the line of symmetry. So these are all inverses.